this Passive House and All Electric Homes training series to you all. These trainings are at no cost, thanks to the sponsors of Energize Connecticut and are part of a partnership with Connecticut Passive House and Build Green CT. And today's training will be recorded and made available online afterwards. A reminder, as part of this training and workforce development initiative, the sponsors of Energize Connecticut also offer 75% cost reimbursement for individuals pursuing either FIAS or PHI professional accreditation. This includes the cost of the trainings and the exam. And once you become certified, you can submit your application for the 75% reimbursement. If you have questions about that process, please don't hesitate to reach out to us. Next slide. Yeah. Oh, no, right there, Shannon. Yep. So in addition to the no-cost educational training series and the professional accreditation reimbursements, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to go all electric with their residential buildings or pursue Passive House certification in their multifamily projects with 5 units or more. The Passive House incentive design for Energize Connecticut is shown here. Includes pre-construction incentives for feasibility studies and energy modeling, and post-construction incentives for full Passive House certification through either FIAS or PHI. Next slide. The all-electric incentive for both single-family and multifamily buildings. It offers 2 levels of eligibility with specific design and performance requirements associated for each, and has incentive amounts ranging from $1,500 a unit for multifamily up to $10,000 for single family homes. Our goal ultimately is for everyone involved in the construction of residential buildings in the state of Connecticut to be aware of these incentives. So if you're interested in learning more, please visit our website or contact us after today's session. So for questions during today's session, feel free to use the Zoom Q&A feature to communicate questions or comments to our presenters throughout. And a reminder that today's session is approved for both AIA credits, which you would have provided your AIA number at the registration, and FIAS CEUs. The self-reporting number is shown here at the slide, and we'll share that again at the end. So with that, I will introduce today's speakers and turn it over to them. Up first, we have Shannon Pendleton, CPHC and founder of Sanderson Sustainable Design. We also have Ilka Cassidy, CPHC and co-founder of Holzrum System. Steve Hessler, also co-founder of Holzrum System, and Tony Lasanti, the managing director at Integral Building and Design, and the QA/QC manager for FIAS. So Shannon, take it away.
Thank you so much, Keegan, and thank you, Kate. Really appreciate you both, and am looking to find my notes and having a little trouble. So give me just 1 second. All right, I'm going to do it this way. Okay, can you see it now? Everything look all right?
Yep.
Give me
Yeah,
thumbs up. All right,
Shannon.
great.
Yep.
Appreciate your patience. Thanks, Kate. Thanks, Keegan. Welcome, everyone, and thank you for coming. You all are very lucky. I want to take a moment to recognize Energize Connecticut, United Illuminating, Eversource, Build Green CT, and of course, Connecticut Passive House. The great work you're doing, the incentives that you're showing makes me want to move to Connecticut. So thanks for inviting us today. I am Shannon Pendleton, and I lead Passive House projects at Sanderson Sustainable Design. I'm also a co-host on Passive House Accelerators Construction Tech. Come see us every Wednesday. And I serve as a materials expert at Source 2050's High Performance Marketplace, so you can also find me there. I'm excited to kick off today's training with Ilka and Tony and Steve on Passive House Prefab, design integration, and site verification, where we'll be sharing some of our work and case studies and best practices to help you dive in deeper to your Passive House and prefab education. So for today's agenda, I'll be covering design and prefab and why that's a good fit for Passive House. And Steve and Ilka will cover modeling and expose the difference between typical 3D models for construction documents versus the needs and opportunities that manufacturing models have. And Tony will dive into checklists and how raters and verifiers conduct inspections and grade both in factory and field assemblies during shipping and rigging and setting to ensure quality assurance, quality control, capture all the items that Passive House certification likes to see. So if you asked us, all of us, what's the one thing we want you to remember today? For design, it's create a discipline of decision making, come up with a strategy and work it into the plan. For modeling, it's you have got to model it to build it. And then there are endless opportunities. And to verify, if you can't see it, you can't verify it. It's one thing to pass the blower door and another thing to build a building that lasts. So a little bit about my firm at Sanderson Sustainable Design. We combine building science, community advocacy, history. We offer passive house modeling and design build prefab solutions through proven techniques. And we do this for clients, we do this for teams. So we like to help other architects get there. And our goal is to have a positive impact for our colleagues and communities by promoting local bio-based materials, life cycle cost analysis, off-grid resiliency, and real-time monitoring. So pop quiz to kick us off. Can you find the prefab in this picture? Which building here do you think has the most prefabricated parts? Well, if you guessed the building on the lower left, you got it. And this is a case study we're going to go through later in the training. But before we dive in, let's ask at a high level, what is prefab? And why is it great for passive buildings? What are the benefits? So what's your idea of prefab? What do you think it is? Is it handmade building panels, trucked to the site, pre-manufactured roof trusses, off-the-shelf ready-mades, or a robotics factory that makes cuts and connections by computer? Do you have to have a crane? Are we gonna call it prefab? So what we've found is that, like most of our industry already, every prefabrication shop is different. But a commonality among them is they like to focus only on their scope, and they typically won't offer clash detection or the ability to see deep into the design to make sure all the parts fit together on the project before it's delivered to the site. That is ultimately and legally the architect's job. So it's really important that the architect works with everyone on the team, the prefab company, the builder, everybody, the passive house consultant, to make sure that it's all captured in that design process. So take a deep breath. The good news is we're going to show you today that you have a lot of help and the buddy system is real. So the big takeaway is, before you decide what kind of prefab you're considering, consider the goals for your project and why one shop will yield more benefit than another for your project. And prefab is typically broken down into three things: panels, volumes, and complete structures. And within these categories, there may be ready-mades for walls or floors or roofs or rooms, sometimes called pods, modules, and sometimes just fully finished buildings. So the volumes category, also commonly referred to as volumetric modular or volumetric high-rise, has a really increased potential for scale and density. And it's typically assembled at unions between those called marriage joints. Each of these categories can then further be developed and delivered on a spectrum of both complexity and scale across the typical building scopes for structure, where you might use wood or CLT, steel or concrete, sometimes with pre-cut openings or mechanical penetrations, across fixtures to include pre-installed windows, interior walls, drywall, don't let it rain on your drywall when you send it to site, exterior cladding, and sometimes mechanical, electric, plumbing, raceways, ductwork, and sometimes even the equipment. And finally, functions. So if you're offering an entire wall assembly system that's pre-finished or is ready for cladding, or entire rooms or completely serviced buildings that are often referred to as turnkey solutions. So all of these options can be delivered in part or in whole, as long as they fit on a truck and on the highway to your site. And when you meet your prefabber and you make a match and you sit down to talk, you're going to go through Google Maps and you're going to fly to your site and you're going to make sure that there are no trees and wires between your building and its access points. So hopefully you can see this video that's playing. Sometimes it's a little laggy, but even though our focus today is on new construction, it's helpful to know that there are many options for existing buildings or that are options for new buildings that can be used on existing buildings. And it's important to model these with passive house techniques as well, because if you don't define the moisture and vapor profiles in your walls, your roofs, and your floors, Mother Nature most definitely will. And those guys taking a bow, they're coders. They coded the 3D printer to build those panels. They're not contractors, but they did a pretty good install. So back to why does this benefit passive buildings, this prefab technique? In short, it's time, money, and materials, or the project's process, budget, and specifications. More than that, it's a mindset. So yielding the benefits on your first project requires a real shift for most teams. And the great news is those shifts are right in line with what Passive House likes to see. Basically, you're doing more work up front in the design build process, and you're thinking like a design builder, not just a designer. So that means it's going to be more integrated. There might be an early drawings release package, a design freeze. It'll definitely change a lot for your design process. If you're a builder, it's going to change your contracts and your fees. And like Passive House, it really wants you to be on the team early to talk about sequencing, materials, scope split, and what you would do differently. You know, we designers, we want to know what you would do differently during design, not when we think it's all done and we're ready to go for CDs. So these 3 timelines are all examples of project workflows across the standard phases that we're all used to for project development, schematic design, design development, construction documents, construction admin, and project closeout. The typical site-built project is on top. The prefab is in the middle, and passive building is on the bottom for certification. And what is interesting is there's very little on that one, because when you throw the prefab one up there, it takes care of a lot of what Passive House already wants. So basically, you know, in the typical site built, you'll see how long the geometry changes. It can change through construction documents. And when pricing occurs, it occurs at a point in time. Whereas with the integrated prefab system, they want you to freeze that geometry early, get into the prefabber's queue or line, and you wait in line. So you want to send them that frozen geometry early so they know what they're going to be manufacturing. And then you can continue to maybe move the parts around that they're not going to make and continue with those. So you might just shift in your design process what you're working on and when. You might have an early drawings release package, but then pricing can occur for a longer period of time, beginning in design development and following through as far as you want it to. What we definitely do after we freeze that geometry is get into the contract negotiations. And this really allows for a lot more upfront purchasing to alleviate supply chain concerns and give us more time to discuss operations, maintenance, and monitoring instead of change orders and whether or not some materials are available. So it also helps to have strategies and narratives for those strategies and diagrams for those strategies to define the goals for your whole team so they can not only talk about it, but see it. And this is the way off and on-site teams will know how to hand off to each other and make sure the critical envelope connections and penetrations are maintained and you have continuous air sealing and continuous insulation. So for control layers, this part of your process, it really is Passive House and Prefab both like simple shapes. They like good form factors and strong window to wall ratios. And they want you to define the water, the air, the thermal, and the vapor continuity in that order and very clearly on all the drawings. So then really Passive House wants you to define those control layers and draw a red line without picking up your pen in order to show how they'll come together at the marriage joints between either the below grade walls and the slab, or below grade walls and above grade walls, or above grade walls to the roof. And for prefab, how they'll come together at the marriage joints between the shipped parts and the connected penetrations. And lastly, these diagrammatic understandings have to make their way into the details. Where is the air barrier in this typical building section? Builders, if your architect sends you a drawing like this, send it back and ask them, where is the primary air barrier and why? And in the following slides, you're going to see really complex examples of how to do this right, even when the details get deep. So hang in there. This is a great timeline for the case study we're about to see and run through. But what this summary shows is what was different. It's highlighted in orange, but right after schematic design, we froze that geometry. And right after design development, we got some early building permits and did an early shop drawing review just to release that drawings package to the prefabber. We also got an early window and door order, so we knew our windows and doors could go to that factory because we wanted them to pre-install as many windows as possible. They could do all the ones above grade, but the ones below grade we did ourselves. And then, or I say ourselves, the contractor did them on site. And then the larger door units that needed to be molded together were also done on site, which you will see. But then there's the date the windows had to arrive at the factory for us to stay in their queue. That happened, which was brilliant. And then we had our kickoff meeting on site. The panels arrived. Some of the benefits were a materials control, a time control, reduce waste. And our builder was a first-time Passive House builder. So this saved them from installing a lot of windows, which is often one of the trickier spots that leaks the most when we go to do that blower door test to be airtight. And they tested those in the factory and they sent us panels with pre-tested, pre-installed airtight Passive House windows. Some of the challenges: location and site access. We had a small site with very little staging, so it actually helped. The project size requirements, it was a big project for us, but for the prefabber, it was really small. So, you got to find the right fit. The zoning and permitting, Tony's going to talk more about that. Steve and Ilka might touch on that as well. Make sure that what you're going to deliver, your inspector knows is coming and that they're going to be okay with it and they don't hold you up on site. Panels versus components, there's very different requirements for certifying those and inspecting those. So just make sure you know what you're making and what you're delivering and who is the inspector that's going to certify it and put that sticker on for you. And it pays to be near the factory. We were pretty close. There was less on-site do-it-yourself, and we still had a lot of local workforce development, but it meant the builder who liked to do things the way they always did things had to do it a little differently. For cost, for budgets, buildings are just expensive, and it's all about choices, right? Do you want granite countertops or high-end mechanicals that deliver HEPA filtered air 24/7? If you're building an affordable building, the benefits can fluctuate based on which manufacturer you choose. So really look at what goals you have and what that team is offering. That enhanced security, the site security, the schedule security, the safety. There's a lot more safety in an indoor space than on a building site. The supply chain, the early decisions, the bulk orders, the dimensional stability. Our wood was beautiful, very straight, very true, very dry, reduced dry time, and no weather delays, right? It just does not rain inside that factory. And the workforce training was great. So for budgets in terms of prefab, this has really been proven out many times on this slide by Science Direct and Harvard University, taking into account the reduced materials, the reduced waste and time. And for passive house, that return on investment has also been proven out many times. And before incentives came to Massachusetts and Connecticut, this slide on the right is showing the Philadelphia Housing Authority's cost analysis between 2015 and 2018, showing how passive house tunneled through the cost barrier and actually came out lower than conventional construction in 2018. And what that's an example of is that when you start to work with an experienced team, it starts to get easier, you start to get better, and you start to really cost optimize in the design process and in the build process. And if you're really good, you end up paying for your services by energy modeling and pulling out insulation where it's not needed, putting in high performance where it is needed. And you can show them, look, we just saved you this much money by pulling out all that insulation. I covered the cost of my fees. Isn't that great? Or maybe use less solar panels. Isn't that great? So that's the idea. For specs, getting into the materials now. So FIAS has requirements that estimators just love. These are the Dropbox screenshots for what FIAS is going to require during certification. And each of these specs that you have to upload into these folders is going to be vetted for performance, for moisture, for comfort, and for condensation risk. They'll also require that energy model, the coordinated drawing sets, manufacturer's testing data, and then the checklist that Tony's going to rock for you later in the presentation for Energy Star, Indoor Air Plus, and Zero Energy Ready Home. But not only the estimators like this, but the prefabbers like this, because it's really easy to price something when you know how it's going to perform, how much of it you need, and how thick it's going to be, and then where you're going to buy it. So you can see here, there's the data sheets and the specs. And when you open that up, everything from HVAC through the roof hatch. And when you open up something like insulation, every kind of insulation you could imagine. And if FIAS hasn't heard of it, they will work with you to find a method for getting you through certification, and hopefully you'll pass. The other added benefit of choosing your specs early is you can really drill down on carbon. You can see from this slide right here on the upper right, a typical building's embodied energy is the same as a high performance building's embodied energy. Sometimes it's even more because you're using more insulation maybe. But really from cradle to gate, these materials make up half of our carbon footprint. So, I think the big takeaway here is keep it local. Find a prefabber near you, or one that, can ship overseas, maybe that, is cheaper than trucking it across our country, or has a better carbon footprint than trucking it across our country. Believe it or not, that's a thing. And then break it into the schedule. It can take a long time to figure out exactly how it works, but you've got this. So let's dive into the case study. So this is a really interesting project that Stephen Ilka and I did. And we decided to prefab very early. We picked our prefabber very early, Blueprint Robotics in Baltimore. We ordered our windows from Germany and had them shipped right to their port. They pulled them off and they brought them into the factory and installed them airtight. Everything purple is mechanical. Everything green is our air barrier. That brown is a wood fiber insulation. And then we did all the beautiful on-site stuff that makes it look like a building that has always been there. Or maybe when the landscaping grows in, will look like a building that has always been there. So this is a great shot across the front, and it really does keep sliding across. But in the interest of time, I'm going to jump forward and show you what they did in the factory. So our factory has airtight panels with a thermal buck on the exterior. That's that exterior wood fiber insulation that kind of creeps into that rough opening. So when they pop that window frame right here up into this window opening, this rough opening, it lands right on this thermal buck. And we could secure our wood fiber insulation because they're buying it in bulk and they're ordering it on time and they know exactly when they're going to install it and they can stage it. They've got room. So my menu's in the way. Give me just a second here. This is the below grade accurate foundations. So these were all done on site, but they had to be accurate to within an inch, or I'm sorry, an eighth of an inch. Let me get my numbers right. And the prefabber comes out and checks this. So what they really want to see is accuracy. If it's not accurate, they will not deliver. They do not want to put their product on a faulty product. So if you're going to wear a great outfit, make sure you've got shoes to match. The continuous insulation and air barrier below grade, we picked an insulated concrete foundation system that packs flat and was an R41 EPS instead of XPS, because back then, even XPS didn't have good blowing agents. So we made the best choices we could make there. And it also made it easy to get that air tightness and that super insulation continuous, because it was like Legos. The builders stacked it up. Below the slab, we have continuous insulation again on top of a glass gravel. So right here, we've got our foamed glass gravel. It's an R4. We had about 11 inches of that. It replaced typical gravel. And then on top of that, we had our wood fiber. And then inside that wood fiber, sometimes we had things like structural thermal breaks where we knew the steel was going to go and had to land on a footing. So there's a footing underneath, and on top is this thermal break, which is also structural and has a great compressive strength. And then around that is that wood fiber, or excuse me, the mineral wall. And then the air barrier membrane on top of that. And that's our air barrier at the basement level. So once that goes on, they can pour the slab, but they've got to tape all the seams. They've got to tape all the penetrations, and they've got to make sure that that air barrier comes up from underneath the slab and connects directly to the wall. So that's what you're seeing in this area right over here. And the suspended slabs, once we got above ground, we got our steel set. That steel held up some suspended slabs. So these were ready-mades. They came much like the ICFs came, and they were put together in sections. And then the rebar was laid in, and then we poured on there, and we had a slab to park on, because this is a 1 grade on this level and 2 stories on the back. So they could drive in and park on this suspended slab, and they could walk out the first floor and hang out on the terrace on this suspended slab. But both are super insulated, and they protected the interior conditioned spaces below. As I mentioned, the wood was gorgeous. These are FSC certified lumber, prefabbed interior walls. So, we got a little carried away. Once we started to prefab, we were like, well, what else can we prefab? Can we do the soffits? Can we do the interior walls? Can we create knockout floors for our phased elevators that aren't going to go in for a while? Yes, you can. Here are those beautiful wall panels, which was a holes room design. This is a zip barrier, but not like you think about it. This was our interior air barrier, and it's a more European assembly where it's vapor open, but airtight. And the, as you can see, when we turn it around, the wood fiber is wrapped with a really beautiful MyVest vapor barrier that's got a smart vapor barrier to it. So, or vapor retarder, I should say, because it lets vapor in and out. So the wall can breathe. Here is a good example of that wall coming up and where we had to transition that air barrier from below grade to above grade. So you can see they brought it around the ICFs, put it under the or over the sill plate here, and then held it down, and then flew the panel in and set it on top. And then from the inside, they picked it up and taped it to the wall. So that we had to talk about before they got the panels on site, because I can tell you, when they're flying panels, they don't want to talk. The sequencing between the exterior prefab walls and the interior prefab walls. Where are you going to make those connections? How are you going to fasten them? And how are you going to ensure that you aren't penetrating that air barrier? Same goes for the ceiling, and where the prefab trusses have to land on those plates of the wall and the top plates of the exterior walls. We had to make sure that we had little leaders, little floppy bits here on top of all of our walls, so that when the trusses got laid down, we could go back and connect all the ceilings. Speaking of ceilings, there's our air barrier truss cord kit ceiling going in underneath that ceiling that you just saw the leaders for completed. So here are the other pieces taped to those leaders, airtight. And then this kit ceiling went in underneath it. Here's the interior of that wall with the openings already created, very precision rough openings with the thermal bucks. And here is a site installed door and transom, which had to be molded on site and installed on site, and it fit perfectly. So that's where the architect really earns their bread and butter, because they're checking all those shop drawings before the windows are made, before the walls are cut. And then the site installed door assemblies, this is where the on-site guys shine. They put in this door system so beautifully, and we had ADA recessed door sills. So, making sure our slabs and our floors would accept these versus the ones that weren't ADA recessed, that was always a little tricky thing to have a conversation about. And then also, here's our wall where our above grade is meeting our below grade. Our mason wanted a cement board before he started putting on all of his masonry. So you really want to have conversations with every sub if you can, including your systems subs who are going to do the install, because the designers are really working hard to make sure all these systems meet Passive House, fit in your mechanical room, have all the clearances they need to prevent condensation risk, and deliver the efficiency that you need to pass, or the hot water piping lengths that you need to make sure you're going to pass the water requirements and the energy requirements. So if you're going to go off grid, you want to have that conversation and talk about what you're going to do with your electrical panels and how those are going to snake their way through the building. We had CT monitoring clamps, an off-grid sub panel that we put our off-grid items like fridges, heating, cooling, septic pump, a couple outlets, and our Wi-Fi enabled modem. And we get real-time monitoring out of this with no subscription. So it can be done. And you can also use what's called a single integrated network and only buy one set of wires instead of a bunch of proprietary wires that require subscriptions to use them. So here we go. We're almost done. The sequencing at the exterior finishes in the timber frame. All we really care about when this goes on is please don't penetrate that air barrier. And if you do, please tell someone so we can fix it while we can still see it. And then they really did the finishing touches. We went through the certification process. There's that on-grade garage. There's that above-grade terrace. And here are the beautiful certifications that we received. These are the results. And we had an excellent team for this. I should have put a team slide up, but you can see it on the Fiat's website. The whole team's listed there. And really, we got big kudos from the client, which is the ultimate test. So again, our huge, big prefab takeaways are: stick to your knitting, don't knit in a silo, and find a knitting club, find a friend, and find some experienced friends and match them with people who want to learn, because greener buildings give you a stronger grid. And thanks so much. I'm going to hand off now to Steve and Ilka, and I guess to Ilka first, right? And enjoy the rest of the presentation. Thanks so much.
Okay, hello. Let me just figure this out. Okay, so is this all good?
Looks great.
Awesome. So yeah, thanks, Shannon. And so Steve and I formed Holzraum System. Steve, do you want to introduce yourself real quick?
Sure. I'm Steve Hessler from Holstrom System. I do a lot of the modeling and panel design, and both Ilk and I are CPHCs, and we're really thrilled to be here.
Awesome. So yeah, I'm Ilka Cassidy. I'm a CPHC. Together with Steve, I'm co-founder of Holzraum System, and then co-founder of C2 Architecture, and I'm also co-host on the Passive House Accelerator podcast and the live events. And yeah, I'm really happy to be here today and share a little bit about the work that we have done. So what we are going to show is based on project work that we have done, basically starting out as an architect builder team between Steve and I, and then as Holzraum System, specializing in passive house and DFMA work. And we're going to talk a lot more about DFMA, which is design for manufacturing and assembly, a little bit later. But Holzraum System basically became a link between the architect builder team and the factory. So we never produced panels, but we always formed really tight relationships with manufacturers. And at this point, we are actually shifting our focus away from the actual DFMA work towards scaling this approach by consulting and educating and teaching what we have developed through the project work that we have done. So we are actually currently, and we're really excited about that, working with McGill University in Montreal to develop a passive house design for manufacturing and assembly curriculum over the next 6 years to get the next generation of students ready for a different way of building and thinking. So we are, hopefully expanding that curriculum into the US for students and professionals as well. So first, we will show you some case studies which is basically a progression through our project work because we want to show the challenges and opportunities that come with prefab and how we have solved them. But also to show that there is still a lot of room in moving the design portion towards streamlining the prefab process. So the goal is really to include this process into a workflow and kind of stop seeing it or not see it as something additional or separate. So this is the first project that Steve and I did together as architect and builder. It is a high-performance home using all the passive house strategies that we had learned in the FIES training. Besides the passive house as aspects, it was built basically as traditional as it can get. And although the design was almost as simple as it can get, we felt like we had to reinvent the wheel like over and over again. So clearly there was a more streamlined way to do that. So that led us to our second project together as architect and builder. Also a very simple, straightforward design. We were ready to use prefabricated panels and started working with BuildSmart, who unfortunately doesn't exist anymore at this point. But this was a system based on very specific dimensions with predetermined window sizes, placement within the components, and basically just one window and door manufacturer that we could use. So we kind of made this into a game to play the system and solve this kind of building puzzle. But those were only exterior wall panels, load path, interior walls, and roofs still had to be site built. So the next project was this one. The design was very much dictated by the client and basically down to the exterior trim, very unique and custom. So we knew that this would not fit within BuildSmart's constraints. And soon, as soon as the standard components become custom, there is really no cost efficiency with a system like that anymore. So we also became more educated about the benefits of using natural materials and decided that we didn't really want to use any foam above grade anymore. So instead, we wanted to use wood fiber insulation to guarantee a vapor open assembly and a low carbon footprint. So we started working with Blueprint Robotics, which is a fully automated state-of-the-art prefab facility in Baltimore, who agreed to, at this point, unconventional wall and roof assembly. So, oops, sorry. So what happened though is that we had to make sure that the manufacturer really understood what we wanted in terms of design and passive house detailing. We also had a fully load-bearing prefabricated timber frame as well as a prefabricated stair, and everything had to fit together. So not only dimensionally, but also per install sequence. So everything required high level of coordination and tolerance delivery. So, and since Steve had to model all the timber components and the high precision millwork in his CADWorks software, we started to model the rest of the building as well, including all my 2D passive house details to communicate everything with Blueprint robotics. So what we saw here was that there was quite a bit of a disconnect between the architect builder and the manufacturer in terms of communication. Like, it sometimes felt like, okay, we had our, in the beginning, our 2D drawings or our Revit model, and we just kind of threw it over there. But it was really hard to communicate all the really intricate little details that needed to be met for Passive House, for all the different components, and per the client, all the detailing that he was requiring. So what we weren't able to include at this point was MEP content. So, but at this point, our, we put our heads together and a light bulb went off and we realized, we learned so much through this process in terms of communication. How do we really show the manufacturer what we really want? We modeled this. That really became our first strategy, modeling, exporting it into a format that they could read and actually use. So we kind of, thought this is something that everyone could benefit from, and we started our own business with Holzraum System that really specialized in this kind of intersection or this crossover between the architect builder team and the manufacturer. So that was our first project with Shannon as the panel designer and consultant to another architect. So it was Shannon, and then she used a builder who had actually never even heard of Passive House before. So here we had to figure out how do we get all the information we need from another architect. So, and this is actually a way more complicated than you would think, and made us realize that communication amongst team members is a really, really big part of this prefab process, right? Not only between the art, like what we developed or discovered before, between just moving design intent towards the manufacturer, but also now being the consultant, how do you actually get that information in a streamlined way out of the architect? Because not everyone needs to know everything, right? So here, as I said, we worked with Blueprint Robotics, and they wanted to streamline the process on their end. So they really wanted us to use their software. So they gave us licenses to the Dietrich software, and we learned that. And we started thinking about kind of an approach that is not necessarily just focused on what the manufacturer is doing, but also thinking about, okay, now we have this model, and what else can we kind of put into that model? What else information does team members need and want and can give us? So the problem, though, with this approach with this project with the Dietrich software was that the software is very much a manufacturing software and not very nimble. It was very focused on the Blueprint Robotics, manufacturing process. So, and that actually changed a couple of projects later. So we always had the idea to work with several manufacturers and determine who is the best fit for the project in terms of location and design. And here we started working with New Energy Works in upstate New York, who at this time didn't have an automated manufacturing facility. They do now, but back then they had a warehouse and workers who built the panels by hand, basically. So the opportunity we had here was that we could really dig into and learn what we can do with this kind of single integrated manufacturing model or expanded DFMA, which we're going to explain a little bit more. But we could stay within the CADWork software, which Steve has been using for over 20 years. So by starting that and using, we started using this model in many ways and discovered all the incredible opportunities that it brings with it. And we'll talk about that later as well. So yeah, we felt pretty good about this process and what we had figured out until then. And then this project came along. So this is a hybrid. It has a CLT roof and floors and prefabricated framed walls, but not from the same manufacturer. So we realized that once there is one model that integrates all components, we actually can make a system out of all the different components, and it doesn't matter where they come from. So on top of this, we started another hybrid project. This is a hybrid of CLT floors and roof, but with site-built wall panels, also integrating a very complex prefabricated steel staircase. Again, this is a bit kind of an experiment at that point. But what was really exciting is that we kind of came full circle, that we have the opportunity on a couple of very complex projects to be the architect, passive house consultant, and panel designer. So what we really wanted to investigate now that we have all the drawings in our hands was how do we really streamline the process between architect and panel designer? So how do we avoid redundancies in models, decrease review time, and take advantage of all the information of the SIM, the single integrated manufacturing model, in our architectural documentation? So, and then, of course, how do we make this all affordable? Obviously, all these projects are not really that. We're very thankful that these homeowners basically became our investors, allowing us to develop these strategies, which are now benefiting more accessible prefab solutions. So this is a project that was the first one with a repeat project team and similar design, where we could start thinking about standardized details. So let's talk about the difference between a volumetric model and a parts-based model, because this is really the key of this whole process. So the architectural design process, or in the architectural design process, what is really the information we need to develop and communicate in a streamlined and clear way? So we have the design intent, and we need plans, sections, 3D renderings, and then we need the outputs. We need interior finish and window elevation, and basically a schedule that captures all the information. And a program like Revit or Vectorworks really does a great job with that. So in the volumetric model, we define wall assemblies that we can change easily. We can make windows bigger and smaller or delete them in seconds. We have parametric symbols for windows and furniture, but to keep files and operations quick and user-friendly, the information that is contained is targeted towards the architectural process and documentation. So actually works similar for a parts-based model. So what is the information we need to build panels? We don't really need to know what the tile specs are. We do need to know exactly where each piece of lumber is, what species, dimensions, and how it attaches to the next piece of lumber. So all the data information is attached to each element of those parts. And while a parts-based model is parametric to a certain degree, When it comes down to manufacturing fidelity outputs, changes and elements become manual and very labor intensive. So that's why, how Shannon said, you have to lock your design intent in early. That's why it's so important, because if you do it later, it becomes very, very hard to change all the little parts around. And this is what something like that looks like. This is a panel. This is panel drawing. And the outputs from a parts-based model are very different. They must show all the information to build the panels as well as how to install them. And Steve is going to talk about the different software that can be used.
Thanks, Silke. Let me share this one. Okay, you see that? Okay, so Ilka did a good job of covering what the BIM programs do. I'm sure pretty much everyone in most people in AEC have had some kind of interaction or used the BIM programs. We're going to talk about a few other AEC related modeling programs, including production design software, Nimble modelers, parametric modeling, and IFC collaboration environments. So again, these are kind of some of the standard. I think there's probably a few others I don't have listed on here for BIM programs. Let me just say one thing about BIM is it's not that BIM can't model parts-based. It actually can. It just tends that the workflow usually doesn't include parts-based modeling unless it's like MEP. And a lot of people do use Revit for really exquisite parts-based modeling and MEP because there's some really good tools for that and also some really good libraries associated. But when you get into anybody who's going to manufacture timber components, timber frames, mass timber, glue lams, or any kind of panelization like light frame walls and roof panels like Ilka was talking about and on Shannon's project, then you start to look at programs like CADWork, HSB CAD, Dietrix, and Arkens. Both HSB CAD and Arkens, they sit on top of Autodesk. HSB CAD, I expected it to be a bit more interactive or sort of integrated with AutoCAD, but it really is sort of a European program that's sitting on AutoCAD. Arkens, although I think is quite integrated with AutoCAD. And then the nimble modelers, it really means modelers that are able to sweep, loft, extrude. They can basically create like really complex curvilinear shapes. They also can have CAM, which is computer-aided machining backends. SolidWorks really deserves to be in both production design and nimble modeler categories, and it's a really amazing CAD CAM solution for mechanical engineering and all kinds of other. And there are a few people that are using SolidWorks for AEC offsite construction as well. Grasshopper, so parametric modeling, I mean, really, it's not the perfect term, but we're using parametric modeling. If you can imagine that you could just write a script, this little box over in the top right is the programming environment in Grasshopper. And in Grasshopper, you don't have to be a sophisticated coder, but you can essentially write programs that can create all different types of geometry into production design software. So it sort of marries like the ultimate creativity with programming, and then also can feed it right into programs like CADWork that can then do their production design thing, which we're going to go into a little what it looks like to walk through a DFMA project. And so if you can imagine having the power of something like Grasshopper and then be able to just move that right into the right workflow, which is DFMA, there's going to be some exciting things coming up. So IFC format. IFC is a format, industry foundation class. It's managed by the Building Smart International group. And it's been around for like 30 years, but it's finally really coming into its own. And what it allows you to do, the idea is that all these different software programs, they tend to be very siloed workflows in AEC. So something like IFC allows you to move models with data attached between all these different software programs and workflows. So really quick, DFMA, Design for Manufacturing and Assembly. It started with a company called Boothroyd Dewhurst in the early 80s, and it really took off in aerospace and automotive industry. Essentially, it worked really, really well, and it still does in those types of industries where even though you have multiple factories and design departments that are all working towards a common sort of product, when DFMA moved into construction, it just got really very siloed along the different type workflow needs that everybody had. So, you know, people that were doing the design, I don't know, there's so many different BIM programs. And so it just got really, really fractured. And so what Ilka and I have been doing in our work with Holzherm is trying to bring it back together. And it's essentially bringing DFMA back to its roots, but we call it expanded DFMA. So yeah. So here's what it looks like. I'm going to move through this pretty quickly, but this is sort of like from the beginning of a project, right? We get a lead and we're looking at a project and we think we have we think we know what kind of offsite components could be integrated into the project. We have to convert the design intent. We'll ask for models and drawings and 2D sketches, anything you want. Any of that information, we bring it in to try to understand what the design intent is. And then we convert that into a simple rough order of magnitude pricing model where we can extract quantities and data for factories to price it. Sometimes that can be quite complex. This is a hotel that we're hoping to do with New Energy Works in Woodstock. And there's 3 versions shown. So the version on the left has just offsite panel, floor and roof panels. And then the one in the middle has CLT core, stair towers, and elevator shafts, and a few other components. And then the one on the right is sort of like a lot of wood. So we'll see how that goes. But you basically, same process. You just want to really figure out what are the scopes that could be offsite manufactured, who's going to supply it, and then how do we communicate that for pricing, and then back to the client. Once we get pricing aligned with the client and they want to sign off on a contract, then we need to take that very simple ROM kind of geometry. Of course, we get all updated drawings from the architect, and we need to really move through a process that I'm going to show you that converts it to the contracted deliverables. So all the parts modeling, and we need to do it with checkpoints. And I'm going to show you what the checkpoints sort of look like. So we're going to do this in phases. So we're going to start in GR1. And in GR1 phase, it's very volumetric. We want to make sure we have plate heights. All the windows have to be dead on, and we'll model some load path. And then we're going to move it into GR2, which could actually go from GR3, GR4, GR5. It just depends on what things come up in review. But I'm calling everything that's really towards production GR2 for simplicity. In GR1, we really do model the load path, although even though this looks super like done, it's totally not. It's got all the parts in it. They're all in the right location, but there's 0 connection design. And since there's no light frame parts in the panels, there's just all the relationships that have to be absolutely dead on, and any kind of hardware is not really being considered. But we do want to have the load path in there for the engineer to check it out. When we feel like we're really ready, really integrated, we'll create a set of shop drawings that we call geometry review set. So this is the first one, and it goes out to the architect, the builder, anybody that we feel, the engineers. We want everybody in the factory to review everything and make sure we're all on the same page. We get the markups, and we move into GR2 phase of design. And this is where we're populating parts. It's essentially 2 or 3 times amount of work once you get past the GR1. The GR1 is really just a design gate to make sure we've frozen some basic geometry. We've frozen windows. We've frozen the general geometry of the building, just like Shannon talked about and Ilka talked about. It has to happen as early as possible. So when you come in, you can start talking to a panel company early. You should, but they're not going to really start drawing until you're really close or there of freezing some basic geometry. Otherwise, once we populate some of the parts you see here, we have to manually move them. They're no longer parametric once we kind of populate these parts. And so it's not easy to just scrap all the parts in a wall and then start over. It just doesn't work that way. But now we're doing things like modeling connections, every piece of load path, every relationship from part to part and everything else is part to part, panel to panel, assembly to assembly. We're looking at perspectives like air, water, everything is really kind of built in. There's hundreds of part to part, assembly relationships that we work through. Once we really think we've got it, we now have the opportunity with all these parts to start talking with, really collaborating and doing screenshots that are really kind of exactly what they would like, but look like in the field. And we hone in even closer and tighter. And these are markups from the factory back to us, really talking through, well, how's the air barrier going to follow around this corner, and how are we going to handle that connection? It's all these different perspectives. But the beautiful thing is, with all the parts and model, and considering passive house and everything else, we can talk about multiple perspectives in a single meeting. We are ready. We're ready for GR2. We put together our shop drawing. We're going to send it out for approval. Typically, like I said, there'll be markups. We make some edits, send it back out. But let's just say we're approved, and now we're ready to move into production prep. We're going to be getting ready to produce panels and load path members, like beams and posts that might not be integrated into the panel. So we're going to have panel drawings. This is an example of a single, these 1, 2, 3, 4, 5 images show all the sheets for a single wall panel. So if you can imagine, every single wall panel in this project, there's none there's no duplicates. Everyone's unique. And we need 5 sheets to carry the 5 different layers of that wall, including all the membrane leaders and everything, into production. And so that the people in the shop, they have machines to cut things, but they still have to put things together by hand. Ilka talked about all the different outputs. When you have a model like this, not only can you create shop drawings, but you can also create machine files. So on the left are machine files to cut speed cut parts, like 2x4s and 2x6s of TJIs and LVLs, even with compound angles and joinery and nuts or notches. And then the one on the right is a viewer of a file that handles a bridge. There was a couple pictures of the bridge earlier. The bridge has sort of has like a robot mounted on a chassis, and it can mill and route holes, and it can drill nails. It can drill and nail according to the sheared wall schedules. Now we have to take all of the parts from the approved drawing, and we need to create an installation set. And that's really for the installers to put the panels up. Some of the things included in the installation set would include like these 2 pages are really just some of the details for unique air to water and air connections. So control layers, like Shannon talked about, have to be continuous everywhere. And so when you're putting panels together, you have to think about the transition for water and air from every 4 sides of a panel to everything else it touches, times 60, 70 panels. So there's a lot of typical ones that you want to try to have, but these represent the ones that were really tricky. And so they required some extra communication, and that's what you see. Also, window installations, we've developed, it always changes a little bit per project, but we've developed, we think, a really good window installation. But it gets fine-tuned for each project, and it has to think about what happens on the inside of the window and what happens on the outside of the window with finishes and water and everything. But that has to be communicated as well in the geometry review set and also to the shop drawings. And then my final slide, I think, is one of the other outputs that we really love about these parts-based models are, because we bring in a lot of content. So in the model that Ilka showed earlier, all of the steel that you see, it looks kind of rusted. It was quite an elaborate steel structure that was offsite constructed by others. So in that building, we had CLT panels coming from Austria. We had light frame panels for walls coming from BC. And then we had Montana Steel did all the offsite fabrication of the steel, and they all had to come together. So it's important for us to have all there. And so we'll get their 3D content, and we'll do this crazy clash detection over a couple months. But what's nice is when it's all done, we can do things like this. So what you're looking at is just one moment frame, but we want to make sure that when it gets installed by the people in the field, that they're going to make sure that they put it in the right place, and that those light green things, those are nailers that are going to be, that they have to attach to the steel so that you can, when the panel company gets there, they have something to nail to. Those are just some examples of all the endless possible field support that a production fidelity model can deliver. And that is me.
Okay, I'll pick it up from here. Share. Okay. So just really quickly, what I wanted to talk about is what we are so excited about. You know, of course, the prefab process and everything, but really what I mentioned before, what all those opportunities are that come with a model that's needed, right? So we always say what is really important to understand here is that as soon as a decision was made to prefabricate a model, a digital twin of what will be produced must be generated. So otherwise, prefab is not possible. So, and this is typically what would be modeled by the manufacturer, kind of the typical DFMA, what Steve was just kind of going through. And in this case, it's interior walls, exterior walls, floor panels, roof panels. You know, this is kind of what the manufacturer would build as a DFMA. And what's so exciting here is since we know what is being built in the computer will be built exactly according to instructions in real life, we started to include like other perspectives. So that's the kind of the opportunity. You can start bringing other pieces in. So and this is the load path. The Revit model was actually provided by the engineer with correct sizing of the members. So we didn't actually build this. We got it from another team member. And again, that's why communication has to be figured out and streamlined. All we needed to do was to organize and integrate that. As well as the foundation. That is a piece that's typically not being modeled by the manufacturer, but very, very important, as Shannon said. You need to take care of your shoes, right? So the MEP model was also provided by the engineer and could be integrated and clash detected against the load path with all other elements. And we added windows, and they actually came from the architect's Revit model. And we end up with a holistic parts-based model, which we basically, you know, now understand as the SIM model or the expanded DFMA. So in this case, we also were asked to integrate the terrain. So another opportunity, and that was provided by the excavation contractor. And that was being referenced with the foundation. So what are the opportunities here? So the expanded DFMA can be used as a communication tool in meetings with the team and for field and trade coordination. And it actually gives a lot of control over the process of design for the architect, reviews for the passive house consultant, and communication to the panel manufacturer. First thing that we're trying to figure out way in the beginning. So this is something that can come out of that too. Maybe you don't need to model the entire building, you know, of course, whatever needs to be modeled for the manufacturing process. But, you know, this is valuable just by itself, looking at, okay, what do we have here? How do we air seal this? And passive house detailing instruction, communication with FIAS. And this is something that is very important and what we could develop and experiment with because we are controlling all the drawings. So on the left is a typical volumetric model, and this in this case it's Vectorworks, but you know it could also be Revit. And on the right is an imported SIM model from CADWork via IFC export. So for me, that was actually groundbreaking because now I have all the information in a modeling environment that I am familiar with, and I can manipulate and use it any way I want. So I can use it, you know, to really clash detect. The only limitation is that it doesn't save back. So that is something, maybe it comes eventually, but it's still separate from the fabrication model. So, and this is an example of how you can use this also as an architect for visualization. So the stair and all the CLT is actually an import from the CAD work model, and it's integrated into this visualization in Enscape, something that the architect didn't have to build a model anymore to show their clients. So, and the IFC content can also be part of the documentation. So in the sections details and, content that we talked about streamlining the process, this can now be integrated into the documentation of the architect. So, and the most important though is that I can do a geometry review inside my 3D model. So I overlay my model and the parts-based model and see discrepancies. So a review of the geometry has to be done by the architect, and it can be kind of scary and very time consuming. It used to take me a lot of time, but this way with 3D overlays, I was a lot more confident and picked up tiny discrepancies, and it took me a very short amount of time. So let's just really quickly talk about scope definition and how important it is that everyone is clear on what their scope is, especially around air sealing between, there's this interface between the factory and builder. So this is the foundation, it's the builder scope. The floor framing and load path in this project was also done by the builder. And, the scope description can be very different depending on what makes sense for the project. Here, the roof scope was divided between the builder and the prefabber. And the control layers, so most importantly, the continuity of the air barrier needs to be defined, and it's always a scope that is shared between the builder and manufacturer. Who's responsible for the leaders that Shannon showed earlier, and who's responsible for them being in place? Is it the builder or the manufacturer? So yeah, and sometimes they're integrated in the panels, and sometimes they're done on site. So another interface is the third-party review process, and I'm going to let Tony talk about that.
Okay. Are you seeing the screen okay?
Yep.
Okay. So I'm Tony Lasanti. I'm also a CPHC. We seem to have a group of CPHCs here today, but that's not my primary responsibility. Primary responsibility is one of being a rater or a verifier, doing the on-site QA/QC. And the on-site QA/QC portion is not something that is to be left to the end of this process. You really need to bring the rater and the verifier in as early as possible. FIAS as a brand of passive house certification, you've all seen, or many of you may have seen, this high performance staircase. The worst building from an energy performance standpoint that you can build is one that meets the energy code, depending upon your state and your locale. We show here the IECC 2012. There are a number of federal programs that build off of code. The Energy Star, both single family and multifamily new construction program, that is mainly a performance-based program, but deals with building envelope, site verification, and summaries of mechanical design and commissioning post-construction. Then you have the EPA Indoor Air Plus program, which is a specification, prescriptive-driven program. It's not modeled, it's not a performance program, that deals with emissions, off-gassing, what happens inside the home in terms of indoor air quality. Radon mitigation is a big part of that program. And then building off of those two programs is the Zero Energy Ready Homes program from the Department of Energy, and it too has a single family and multifamily version of the program. If you do all three of these certifications through the HERS rating process, you can then look at FIAS Core or FIAS Zero certification. Oops, sorry. Each of these programs is fairly, strict. They all have their national program requirements. They all have specifications and checklists that go along with them. And with all of this integration, modeling and parts-based integration of panelized construction versus modular construction, what I mean by modular is true box, where you have a finished product, completely finished product leaving the factory. There are some things that need to be done during the design phase that need to be verified. There are some things that need to be done during construction, and there are things that need to be done post-construction and then performance tested. And each one of these programs has sort of hold points and checklists to ensure the quality is built into the building for FIAS standards. So Energy Star, both single family new homes and multifamily new construction, has national program requirements, design review checklists, field checklists, commissioning checklists. The Indoor Air Plus has a specification guide and a checklist. The DOE Zero Energy Ready Homes has its national program requirements and checklists. And of course, FIAS has their QA workbook, guidebook, and field checklist to go along with it. So the rater is kind of a busy person. And that's why bringing the rater or the verifier in early is really a good idea. They need to know the nature of manufacturing. They need to know the critical junctures in whether it's panelized construction or true box modular. This division of responsibility that Ilka, Steve, and Shannon talked about in terms of site work versus factory work versus set work. We need to know who's responsible for what with respect to air sealing, as an example. Oops, I am so sorry with the transition here. All of these programs follow ResNet protocols. For those of you that are unfamiliar, ResNet is the Residential Energy Services Network. They're the standard setting body that writes basically the rules and regulations under which we have to conduct a HERS rating, a home energy rating for a home, for any and all of these programs. They focus on air sealing details, especially important with a passive house because of the air tightness limits inherent in a passive house projects. Insulation quality, and grading. Shannon mentioned this earlier. If you can't see it, you can't verify it. There's very strict insulation quality inspections that are needed. We have to grade the insulation, either grade 1, 2, or 3, or installed, not installed per manufacturer's instructions. With assemblies that come out of a factory, if that insulation is installed in the factory, it cannot be given the grading that it needs to pass these programs. It has to be inspected in the factory. Some factory construction lends itself to being inspected both in the factory and on site. Others don't. What I call panels that leave the factory with soft surfaces on them, maybe a fabric WRB, where you can still very carefully in the field cut into it, get depth measurements, check densities, things like that. That's okay. That can be done both in the factory and in the field. But when you have a completely finished panel or a box modular that has hard surfaces, even paint and finish on the interior, that has to be inspected in the factory. The HVAC design, testing, and commissioning, the integration of the HVAC components, some of them might be installed in the factory, some of them might be installed on site. How they get tied together, those systems need to be inspected, verified. Duct leakage testing needs to be done. Post-construction, airflow measurement, air balancing for the heating and cooling and the ventilation systems needs to be conducted. I mentioned already duct leakage testing. There's performance targets for that. Of course, the blower door test, which everybody seems to focus on, but blower door testing really has two requirements. One is a whole building, and if you're doing a duplex or multifamily project, you have to do what's called compartmentalization testing, meaning each dwelling unit also has to pass an airtightness requirement. With a pure panelized constructed single-family home, well, you could do the blower door test as an interim step once the panels are set and sealed, and then repeat it once the home is completed. With a finished box modular leaving a factory, it's almost impossible to do that test until the building is completed, till the home or the building is completed. And even in the factory, to test individual components takes a lot of logistics. To take two modular built boxes and to marry them together temporarily in the factory to do a test takes quite a bit of planning, quite a bit of resources. It's not something that's done naturally by box modular manufacturers. So please keep that in mind if you're planning on or writing that into your specifications. And all other rated features of the home, including windows, the data for the windows, domestic hot water, piping layout, the equipment, lighting, and appliances. All of that needs to be verified. And it applies equally to on-site and off-site construction. Traditional stick-build construction is what these standards were really written for. But as we migrate into this manufactured and more popular manufacturing techniques, such as box modular or panelized construction, the ability to get into a factory and inspect these components is challenging because of the pace of construction in the factory and the fact that the factories might be running multiple shifts in manufacturing the components. It's really important to have somebody as your eyes and ears in the factory. And right now, the only protocol for that is to have a certified HERS rater or a certified ResNet rater field inspector in the factory to inspect these things if you can't inspect them on site when they're delivered. ResNet's in a process of issuing they're going to release soon a pilot program that will test some alternative strategies, but basically visual verification is the key to it. So a word of advice and a pro tip, if you're undergoing any type of modular build, try to get a certified rater or verifier that's close to the factory, that's willing to make frequent visits to the factory to do these inspections, provide photo documentation, and get whatever other documentation you may need for these components. It's also, again, I'm doubling down on emphasizing this, the division of responsibility between the factory, the set crew, and the site construction, or the general contractor that's responsible for the site construction, is really key. And even within the manufacturing facility, the plant personnel, there's a division of responsibility that ends when the product leaves the factory. Does the set crew is the set crew accountable to the factory, or is the set crew independent of the factory? Sometimes there are just set crews that work independently of the factory, and that's what they do. They put Legos together on site. Are they equipped to do the critical air sealing as they assemble these pieces on site? So make sure you talk about that early in the process. Some examples, and this is typical box modular where you have a finished product leaving. You'll see windows installed, taped, maybe several layers of air barrier that are completed in the factory, but yet there are still critical junctions, these marriage joints that need to be dealt with. On the interior, there might be components that could present leakage paths, like valve boxes for laundry, internet and cable boxes, electrical panel boxes, ventilation ductwork, space conditioning ductwork that's installed in the factory that needs to be mated and connected to its partner assembly in the field. So those critical things need to be checked in the factory and then checked again on site where they connect. And here you can see in the lower right, this image, this is a finished box. There's sheetrock and tape on the interior, and yet the exterior is exposed with insulation. If you miss a critical air sealing detail with this type of construction, it is extremely difficult to fix in the field when you're trying to perform that blower door test and you're not getting the target results. A different example of a panelized construction. This is a biodegradable insulation product that is being installed in the factory. This is an example of a panel that's leaving a factory with soft surfaces on it. It has the Sega material on it, and we can see framing spacing. We can see framing depths in the factory provided by the factory personnel. And then these things can be checked on site too, because there's no hard surface once the panels are delivered. So we can spot check the framing depth. We can spot check the spacing and the insulation depth as well. The site logistics that were mentioned earlier by Ilka, they are no joke. The site work, concrete pouring, it's an imperfect thing. These are not finely machined precision finishes. It's wood and concrete. There's going to be gaps. There's going to be irregularities. There's going to be dimensional changes. So how all the parts fit together in the field is, presents some challenges. With panelized construction that has more robotic machining to it, the tolerances are a little bit tighter, but the field mating surfaces may not be to that same exact dimensional precision. Okay, so here you can see a site for a multifamily project. There's a podium that was site built with several vertical structures, elevator shaft and stair shaft that's built. And the modular sections had to be fit very carefully around this. The image on the right is same project, but with the poured columns for a crawl space where the boxes are going to sit. So there's a lot of interfaces. There's a lot of gaps where boxes and panels would fit together that won't be accessible for air sealing once they're set. Here you can see it in progress where we have, basically 3 stories of boxes, another one's being flown in. The set crew for these, this is a rough and tumble game that these folks are involved in. They're lifting several tons of a building component high in the air with closed roads, with the clock ticking on crane permits and road permits, staging. There's a lot of logistics that go into this. Their job is to get these things unwrapped, off the trailer, set on site, and then deal with the air sealing details in between. Okay, so that division of responsibility in terms of the set crew and making sure the set crew is prepared to do the air sealing and to have the materials there and to make sure the materials are protected and they anticipate weather conditions. You got to remember, these boxes are open, they're finished on the inside, and they are very susceptible to weather events like rain. And we had plenty of rain on this project. And you can see as they marry them together, the weight of the boxes bearing down on one another, does tend to make a tight seal on the horizontal joints, but the vertical joints, as you can see in here, can be quite large. Okay, and even with all different types of materials, soft cell material, fibrous materials, to try to fill those gaps and seal them, oftentimes those gaps still remain pretty challenging to deal with on site. Mate wall details. Shannon called them marriage walls. Just like every other marriage and marriage walls are challenging things in life. Okay, and you can see the way the detail is drawn on plan, but it's a whole different ball game when you get out to the field. This is this exact detail right here on the lower right of what's drawn. Some of these gaps were 1/4 of an inch. Some of them were 1.5 inches. Where the gasket material provided by the factory couldn't even fill it. So you need to have contingencies in place on site to fill these gaps, whether it be with caulk, foam, backer rod, tape, all of the above. And the quick fix is not oftentimes the best fix, especially with multifamily buildings and senior housing and affordable housing projects. We want these buildings to last. So just sticking some foam goo in there to pass a blower door test may not be the best approach. A little bit more of a belt and suspenders, something that's going to hold up over time, deal with wood drying out, deal with different weather conditions, expansion, contraction, etc., that's going to last and stand the test of time. Those are the air sealing strategies that you need to have in place for these builds. This is panelized construction, much tighter tolerances just by the very nature of it. You can almost predict where the gaps will be, and those gaps can be dealt with very, very simply. I love this type of construction because once you set the panels, you have some vertical and horizontal seams that can be very easily filled and taped. No surprises with this. It's very, very routine. I love this type of construction as opposed to the modular, which offers much more, many more challenges in the field. Okay, this is the box modular that the earlier images showed. This is what the final product looks like. You can see on the left-hand portion of the drawing the different layers that needed to be added in the field. The green guard material is actually a fireproofing layer that the city required. The OSB behind that all needed to be filled, the gaps filled, taped. This needed to be filled and taped. Then there's rigid board insulation that went over it, then battens, then the siding. Okay, so the multiple layers of things going on, and you needed to determine where your air tightness layer is and which is the priority in terms of the air sealing. Skipping back to the panelized construction, not quite the finished product. This project is still in business. This is actually going to be part of the Bill Green, Connecticut tour in August in Sharon, Connecticut. But you can see it's just simple. The panels fit together. You have a vertical seam. They get bolted together. They're tight. They get taped on the inside and the outside, and it's much more straightforward. So the dimensional capabilities of engineering the process, I have great hopes for in terms of making modular and panelized construction simpler. That's basically all I have. And I'm going to stop sharing. Sorry to run through that kind of quick, but I know we were coming to the end of our session. So.
Thanks, Tony. We did leave time for Q&A. We've been monitoring the chat or the Q&A. So Kate and Keegan, let us know if you've got, I think there's one outstanding question for Tony.
Yeah, I guess that for now, raters can certify compliance with program requirements themselves. Yeah, raters are the independent third-party verifiers. And in the case of FIAS, at the beginning of the project, there's this whole push for design certification. Sometimes design certification, that review that's conducted by the certification staff at FIAS, sometimes that takes place actually after construction begins. But it's actually the rater or the verifier that submits the project for final certification. All of the QA data, photographs, equipment data, certificates, etc., rating files, that all gets uploaded by the rater and put in queue for the final certification team. So they're the ones that kind of put the cherry on top, if you will, at the end of the project.
That's great, Tony. Thank you. Yeah, it was really interesting to hear from everybody. I also just wanted to send a link into the chat because we have a Passive House tour coming up for anybody interested. And I think we have FIAS credits for that as well. So folks who are here might be interested in that program as well. We also had a question, it was answered. If anybody else wants to touch on it as well about Energy Star and zero energy ready homes, and you know, the impact where those policies are now and how this is going to impact.
I'll take that one.
Yeah.
So it's no secret within our industry that the Energy Star brand, as well as the EPA in total, and even the DOE Zero Energy Ready Homes program is
Mhm.
under scrutiny. I'll just leave it at that.
Mhm.
We don't know what's going to happen with the programs right now, and unfortunately, I don't even know if the people that are working on those programs for the government even really know. FIAS as a brand that relies on these, we have been undergoing for some time what life would look like without these federal programs, without the the multiple certifications underneath the FIAS certification. So we're continuing to look at that. Rest assured, they're not going to be tossed out completely. At least the intent of the programs are not going to be tossed out completely. The checks and balances that are built into these programs in terms of not so much the building envelope, because the passive house design kind of takes care of the building envelope, but it's the other stuff. It's the HVAC design summaries, the commissioning, the testing, the balancing, the indoor air quality aspects of the Indoor Air Plus program. Okay, those things, they're not easily discarded by FIAS. They're too important to the built environment, and they tend to be the Achilles heel in construction, right? And so those are really key tenets of what FIAS builds their QA program on, and they're not going to go away. The actual formal certification we'll wait and see. We'll see what happens with the EPA, but this is something that is being talked about actively internally at FIAS. So
Great. That's great information. Thank you. Any other questions? You can raise your hand and we'll call on you, or you can ask them in the chat.
Kate, I noticed the one for carbon. I think Ilka might like to chime in on that. And also
Sure, yeah.
the tour that you just showed, Tony's the rater on that project. So he'll be at
It's
that.
all coming together.
Yeah, he'll be at that. So, and that's
that's
the
a
one.
site visit for me.
Awesome.
Yeah, and that's a unique project because it's straw panels.
Yes, yes.
Yeah, that
Yeah.
is a project that makes me feel like a rank amateur, because the build team on that is they're out there. Just follow their lead.
Thank you guys. That's great.
I'm along for the ride.
Yeah, because some of the build team members, we're not quite sure yet who, but some of them will be there. So, if anybody who's listening is interested in, meeting a team like that, come along. Yeah, and the question about carbon was, what are the embodied carbon benefits of prefab versus on-site assembly? Shannon did answer some of it in the Q&A earlier, but I think if Ilka wants to chime in on that as well.
Sure. So, I mean, Shannon kind of touched on it. I think for me, there's definitely reduction in waste and all of that. But I think for me, the big thing is really that panelization or prefab, it becomes a spec, right? And it's a lot easier for a manufacturer to get materials like wood fiber insulation. Like we had, we talked to a lot of builders, even a few years ago, who for individual projects really had difficulties just sourcing certain materials and products. And then it's very easy for the builder or, the homeowner or whoever to make decisions that kind of go away from those materials, materials that are a lot easier to source are still foam, insulation boards and all of that. So I think for me, going with prefab is the manufacturer can source the products, and then you as the user or the client, you basically spec, okay, I want this wall panel, and there's nobody who can change that on site, right? So yeah, that's for me the big benefit there.
Awesome. Thank you. Appreciate that. I'm not seeing any more hands raised yet or any questions in the Q&A. Oh, never mind. Well, there's a comment. I recently bought a building lot in Fairfield County. I need a company that can pour the foundation, a green one. Are you able to make any recommendations? Or is anyone familiar with a company like that in that area?
Can't say that I am, but I like that they're thinking about the accuracy of their foundations.
We also do have, I'll send a link to our member directory in there. We have a directory of all of our members who do all sorts of various different green building projects, and you can search by, industry type or what they do. So I'll send a link there. That might help as well. Mhm. Any other questions?
I guess we answered them all.
Yeah, obviously. His thorough presentation.
Well, if I can, I'll just take this moment to say thank you. What you are doing for your community, and this is a nice big community, is incredible. And the incentives that still exist in your state, as I said, makes us all want to move to Connecticut or Massachusetts or Rhode Island, or maybe Ireland or Scotland. And thank you for doing what you do.
Well, thank you for joining us at this presentation. I appreciate it.
Yeah, I'll just echo that and thank you all, Shannon, Tony, Ilka, and Steve for sharing your expertise with us, and Kate for moderating today. And on behalf of the sponsors of Energize Connecticut, we thank everybody for attending, and thanks to the sponsors for hosting this training and all the trainings as part of this series. So looking forward to many more, and yeah, excited about that site tour mentioned in August. So folks, encourage folks to definitely check that out. So thanks to you all again, and hope to see you again soon.
Thank you very much. See you all soon.
Bye.
Bye.